Hello everyone, today let's take a look at QP127 where we have two dogs who each arrive at a park for their daily walk at some random time between 4 p.m. and 5 p.m. So their arrival times here are uniformly distributed and they each stay at the park for exactly 15 minutes and then they leave. So what is the probability that they will meet on a given day? So if this is our time interval, right, the hour between 4 p.m. and 5 p.m., then dog number one can arrive at any time with equal probability between this interval, right? So they would arrive here with equal probability that they would arrive right here. And then same with dog number two, right? They could arrive at any time within this interval with equal probability. So they might arrive right here, in which case they would stay for 15 minutes. So it would look something like this. This would be the interval that they were here. If the first dog arrived basically here and they stayed for this long, well then these two dogs wouldn't meet because these intervals do not overlap. So obviously for this dog represented by the blue, this is its arrival time and this is its leaving time, right? It's going to be 15 minutes apart. This interval is of length 15 minutes because both dogs only stay for 15 minutes. So basically this dog could arrive anywhere with on this line. It might look something like this or something all the way up to like this, where they arrive exactly at 5 p.m. and then they stay for 15 minutes after. And again, these dogs are going to meet if there's any overlap at all between these intervals right here. So what is the probability of overlap between these intervals basically? So if we let X be the arrival time of dog number one and Y be the arrival time of dog number two, well then these are both uniformly distributed between 0 and 60 minutes, right? Because we have an hour, we're going from, we can basically say 0 will be at 4 p.m. and then 60 minutes will be at 5 p.m. So those are both uniformly distributed, uniform 0 to 60. So we say basically X is right here, this interval is of length 15 minutes, Y is right here, and this is also of length 15 minutes. So what is the probability that they meet? Well, they're not going to meet if it looks like this, but right at this point right here, they're going to start meeting. When Y arrives at the park right as X is leaving, they're going to be meeting. And then all the way down in this interval right here, and the very last point that they will be meeting is when Y basically leaves right as X is arriving. So if we fix X at some random point between 0 and 60, which is exactly how it's distributed, then Y will be meeting X if it falls anywhere within the range of basically 15 minutes before X arrives or 15 minutes after X arrives. So to put that in math terms, the probability that they meet is just the probability that Y is greater than or equal to basically X minus 15. So it falls somewhere in this region right here, or it could be basically less than or equal to X plus 15. So this region right here. Now, if we subtract X from everywhere within this equality, it's just going to be the probability that basically negative 15 is less than or equal to Y minus X is less than or equal to 15. This is just the same thing as saying the probability that basically the absolute difference between Y and X is less than or equal to 15. So the probability that their arrival times are within 15 minutes of each other in either direction. So if we have X and X plus 15 and X minus 15, then basically if Y falls anywhere within this range, given that Y is basically between 0 and 60, well then they're going to meet. So what is the probability of that? Well, it's just going to be the probability that Y minus X, or the absolute value, is less than or equal to 15. So now let's just make a graph of this where we have X on the X-axis and Y on the Y-axis. So this is what that would look like, where the arrival times of X and Y can only take values between 0 and 60. So now let's plot this function. So the probability of the meeting is the probability Y is between the two lines X minus 15 and X plus 15. So X minus 15, if we plot that out right here, it's going to intersect like so and go up like this. And then X plus 15 is going to intersect the Y-axis at the point 0, 15, and it's going to go up like this. So when Y is less than or equal to the line X plus 15, that's going to look like this entire shaded region. And we also need Y greater than or equal to X minus 15, which is going to look like this shaded region up here. And the only area where they overlap is when red intersects blue. So just the region in the middle in between these two lines. And again, X and Y can only take values between 0 and 60, so we're going to get cutoff points like this, and they're only going to basically be meeting in this region right here, the area between these two lines that we drew. And because X and Y are uniformly distributed, that means that every point along here for X has equal probability, and every point along here for Y has equal probability. So the probability that X arrives right here and Y arrives right here is going to be the exact same basically as the probability that X arrives right here and Y arrives right here. So every point in this entire joint probability distribution represented by this box right here is equally likely. And again, that just comes exclusively from the fact that these are uniformly distributed. So this blue square right here is basically the land of 100% probability. We know that X and Y's arrival times are going to both be between 0 and 60. This is our land of 100% probability. And because they're uniformly distributed, we know every point on here is going to be equally likely. And that property tells us basically that we can just find the probability of them meeting represented by this red region right here by just taking basically the area of the red region and dividing it by the area of the blue region. If these two variables weren't uniformly distributed, so for instance, maybe this point right here might have a higher probability than this point right here, well then we couldn't do it this way where we're just thinking about it in terms of area. But they are uniformly distributed, so they can. So now what is the area of this blue region right here? Well, we could think about it in terms of minutes. In that case, we basically have 60 times 60, the area of the entire probability mass, right? That's going to be 3,600. So now what is the area of this red region? The probability that they meet is just basically, well, this line right here is x minus 15, right? So when we plug in x equals 60, we're going to have this boundary point of basically y equals 45. And then over here, we started at the point 0, 15, and when we basically plug in y equals 60 to this equation for this line right here, we basically get an intersection point of x equals 45, right? And the easiest way to calculate the probability of the meeting is just going to be taking 3,600, the entire area of the blue box, and just subtracting off these white regions right here, which are just the areas of triangles. So this triangle right here has a base of 45 and a height of 45, and so does this one over here. So what you can notice is that we can just combine these, basically think about their area collectively of these two triangles as one square with side lengths 45. So the area of the white region collectively is just going to be 45 times 45. So therefore, the probability of them meeting is just going to be 3,600, the total area of the square, minus basically the complement of probability of them meeting, which we calculated is 45 times 45. And then we just divide that by the total area of the entire square, so 3,600. And then however you want to work this out, basically what you're going to get is 1575 divided by 3,600. And when you simplify that into lowest terms, you just get 7 on 16, which is our final answer. So because we have uniform distributions here, we can think about the probability purely in terms of area, because we know every single point is going to be equally likely, versus if they weren't uniformly distributed, that wouldn't be the case. So we couldn't do it like that. We'd have to take some crazy integrals.